we look at these two shapes, we know the scale factor is K. Now, that's pretty much where we got to last term, where we're talking about scale factor, and that we knew, Callum, we knew that if there was the same sides, and I told you it was similar, that there was a scale factor, okay? And so you could work out what the scale factor was. Can you stop talking while I'm talking, please? Now, we also need to know this other rule. Now, what can you remember from reading yesterday? That we need to know that the lengths, the corresponding lengths are in the same ratio. There's something else as well. It's not about, oh, we did learn about cubed and squared. So if we were looking at the ratio for area, it was K squared. And if we were looking at the ratio for volume, it was K cubed, right? But we also need to know one other thing. So if we look at the triangular prism on the left, what are the angles? What's this angle? 60, okay? Because it's an equilateral triangle, all of the angles are 60 degrees because the angles in a triangle add up to 180, and because they're all equal sides, the angles are all equal length as well. So those sides are 60. Now, if the scale factor's 2, does that mean that the angles in the other triangle are 120, 120, 120? Why not? Because a triangle equals 180, yeah? So an equilateral triangle is still going to be 60, 60, and 60. All right, so what do you think the rule is for, even though these are similar shapes and that one is double the length, all the lengths are doubled, K is 2, what do you think the rule is for angles in similar shapes? Alex? Yep, can you move over here now? Yes. What do you think the rule is for angles? They stay the same, okay? So to prove shapes, so it can be both 2D or 3D shapes, are similar, we must prove 2 things. What are those 2 things? Good. We need to prove, first thing is that corresponding lengths are all in the same ratio. So this is our scale factor, or K, but we can also leave it as a ratio. So I'll show you an example of that in our questions. What's the other thing we need to do? What's the other thing we need to show or prove? All the angles, all corresponding angles are the same. That's what we need to do. Okay, so in some of the questions I'm going to be, well, you should have done yesterday and today, we actually have to prove it. So there's a certain method which we go to proving that 2 shapes are similar. Now I'm going to use triangles to start with, but it doesn't just have to be triangles. It could be a prism. It could be a cube. It could be anything, okay? So it's just to check, but for any shape, we just have to check that the corresponding lengths, any of the sides, are in the same ratio and that all the angles everywhere are the same. And as long as you do that, you can say that those shapes are similar. Okay, so for example, e.g., prove the following are similar. Now, it's not good enough just to say, yes, they are similar. You have to prove it. Phone should be on silent or off. All right, so if I say you have to prove these shapes are similar, what do we have to prove? What do we have to show? That all the angles are the same. Okay, so to do that, we always need to have letters on things. So hopefully they'll give you that in the question. Okay, now the one thing which will help you with this is, remember how in those rules it said corresponding? Sometimes they're not written as perfectly where the corresponding angles are next to each other, and they're not always drawn the same way. Like this triangle could be drawn turned around or reflected. So it could be like a mirror image. So the way which I would make sure that I can understand which sides are corresponding is I would use a highlighter, which you should always have in your tests, preferably a couple of colours. And I'd actually go, okay, so which angle is corresponding to A? G. And if I highlight it, I'm now just looking at the yellow. They're the yellow ones, okay? If I highlight, so which one's corresponding to B? J. Because what happens is a lot of people just get caught up in the alphabetical and they go A, B, C, so therefore it's G, H, J, okay? But it's not. They're not corresponding in an alphabetical way. They sometimes one of them might be, but the other one doesn't have to be. So if you actually highlight the corresponding angles, you're actually just looking for the colours and it makes it a lot easier. Okay, so if I'm saying angle A, now angle sign is just like a little angle, looks a bit like an L, slanty L. Angle A, which one's corresponding to A? G. So to prove it, I say angle A is equal to angle G. But I have to prove every single one is the same, so therefore I go angle B is equal to angle J. And angle H is equal to? No, so angle C is equal to angle H. All right, so therefore, have I now proven that all the angles are the same? Yes, because I've said they're equal. This is equal to this, this is equal to this, this is equal to this. Yes?
Don't you have to write BAC for angle A, like the middle one?
We can just go with there if we want to. If you want to do it, you can. It's up to you. For this, it's not as important. Unless they give you an example where you do all three letters, then you have to. All right, so what's the other thing we have to do? The sides. Now, it's not that the sides are equal to each other. It's that the sides are in the same ratio. Okay, so if I look at the side on the left of the first one, how would I describe that? Yeah, but how would I label it? You know how I've got angle A. How would I label a side? AB. Okay, so we're saying the line between A and B. So we just go AB. All right, AB. Now, which is the corresponding side? GJ. Now, what if I said JG? It's not good. It has to be the same. Okay, so that's why I'm going yellow to blue, and then I'm going yellow to blue again. So I'm going to say the ratio from A to B and the ratio from G to J. Okay, that ratio is what? Is equal to? It is 1 to 3. I would actually start with saying 8 to 24, which is the same as saying 1 to 3. That's what that ratio is. Can everybody see that? Notice that I put the number from A to B first, so it has to be in the same order as what we did. So the AB side and then the GJ side. Pardon? No, it has to be a ratio. So it's 1 to 3. Yes?
If you wanted, could you also say like B, C, and then J, H?
B, C, and J. Yeah, so we're going to do that next. But if you did that first, that would be fine. We have to do all three. So we have to prove all three. Okay, so that's actually our next thing. So let's go BC, the ratio of B to C, which is therefore in ratio to JH, blue to green, is equal to 10 to 30, which is the same as saying, when I simplify it down, it becomes 1 to 3. So this is how we're proving that the ratios are the same. So then last time is A to C, which is the same as G to H, which is 8 to 24, which is 1 to 3. In that case, you could have probably just gone straight to 1 to 3. So now we've proven all three sides are in the same ratio, aren't they? 1, 2, 3. All three angles are the same. So therefore, we need to say that they are similar. Now, how do we say they're similar? It's a little squiggly line. Okay, so we say triangle ABC. Now, triangle, how do we write a triangle ABC? We draw a triangle. Good. Okay, so triangle ABC is similar to, which is that squiggly line, just one, is similar to triangle. Now, it still needs to be in the same order. So yellow, blue, green. Yellow, blue, green is G, J, H. And that's how we prove it. So we go, and I've missed one thing I need to say, therefore. How do you do therefore? 3 dots. So I say, therefore, because I've proved it, triangle ABC is similar to triangle GJH. And that's how we prove it. Are we okay with that? All right. I'm going to give you some homework questions to do, but I'm just going to go through the first question with you first because the last class had a bit of trouble with it and it does go back to some knowledge from last lesson. So we're just going to do exercise 10B question 1 together. So if you want to open up your book, you can. In the new book, it is on page 191. I'm not sure where it is in the old book. I'll just draw it out for you though. So it's got two triangles. And as I said, this is a reminder from last term. It's got a right angle triangle. It says 60 degrees here. It says R, P, and Q, 60, and this says 6 centimetres. The other one says, still a right angle triangle, and it says 4 centimetres, 8 centimetres, and in the question it tells you that they are similar. So because it tells you they're similar, what do you know about them? They're similar. What does it tell you about its lengths or its angles? Angles are the same, lengths are in the same ratio. Okay, so we know that. The question says, find the length of RQ. So RQ is this length here. All right. Anytime you get given two triangles and tells you they're similar, what do you need to be able to work out? Even though it doesn't ask you in the question. We've got to find lengths of sides. How do we find lengths of sides? What do we need to know first? Not the angles. Similarity. What do we know about similarity? That they have the same ratio, scale factor, okay? So what that means is, if we actually look at the two we know, so if I'm just going to highlight this, if I know this 6 and I know this 4, it means the ratio between those two, the 6 and the 4, is going to be the same, as the ratio between, let's say this is X, or actually we'll say RQ because that's what we're looking for. Okay, it's going to be the same as the ratio between RQ and 8. Can you guys see that? That's saying they're going to be the same. An easy way to do it is to work out what K is. Okay, now K is the link between these numbers. So we're saying, if we're trying to find RQ, we're saying from 4, what do I have to multiply it by to get to 6? That's what K is. Whatever number I have to multiply 4 by to get to 6. So how do I work out what K is? 6 divided by 4. Okay, so it's always the second number divided by the first number. So what's K for this? 1.5. So to get to RQ, what do I have to do? Good. I'm going to just times 8 by 1.5 and get 12. So RQ equals 12 centimetres. Can everyone see that? The other way you could have done it is looking at the ratios and going, okay, so to get from 4 to 8, what did I have to do? Hang on. No, they don't link up. Oh, no, it does work. It's times by 2, so therefore what I'm going to do is 6. And times by 2, we get the 12 there as well. But knowing K is probably an easier way to get it all done. All right, so the next question says, what is the size of angle ZXY? So this angle here in green. So how do we work out that angle?
At 90, at 90, 60.
Good. So we know this is going to be 60 because the angles are the same. So therefore that angle is going to have to be 30 degrees. So it's not a very hard question at all. All right, now there's two ways of doing the last question, and the last question is where most people have trouble. Okay, so question C says, find the ratio of triangle PQR to the area of ZYX. Now, there's two ways of doing this. The first way is going, okay, so what do we know K is? 1.5. So therefore the area, so that's for length. What would it be for area? The area is K equals 1.5 K squared. So it's 1.5 times 1.5, which is 2.25. So if we want to know it as a ratio, it will be 2.25, which is the bigger one. So that is PQR. 2.25 to 1 would be our ratio. For every one lot of area on the right-hand one, there's 2.25 on the left-hand side. Now, in a ratio, you can't leave things as a decimal. How could I make this into a whole number? 2.25. If I double it, it will become 4.5. Times it by 4. So I end up with 9 to 4 is our answer there. Now, there's actually an easier way to answer this, though, when you look at these. If we look at our length ratio of, you have to do it in the same order as the question says. So PQR, so we go 6 to 4. That's our length ratio, yeah? Length of PQR to ZYX. That's our length one. Now, what do we do when it's area? Instead of length, we square it. So 6 to 4 becomes 3 to 2. Simplified. Everyone understand where I got from there? I just divided it both by 2. So that is my ratio of for length. So if it's area, I actually just square each of them. 3 squared to 2 squared, which is 9 to 4. See how it's the same answer? So if you actually just use the simplified version of your length, if you square each of the numbers, you'll get the simplified ratio for area. Either way is fine. It's up to you how you use it in practice. It is something you're just going to have to practice. It's a bit challenging, I understand. Okay, so can you write that down? We're going to work on, I know some of you had time yesterday to do some questions, but I'm guessing some of you probably had trouble with it. Okay, exercise 10B, questions 1 to 3 and question 5. If you have done them already, you can do 4 and 6 as well. They're just a bit challenging. But before you do 4 and 6, I'd like you to do exercise 10C. I think it's questions 1 to 15 or 1 to 16. One to 14. And you've got quite a bit of time this afternoon to work on that. Tomorrow, we're just going to do similar triangles and then we're finishing. So if you're having trouble, can you please ask for help? Don't sit there not understanding. Any questions? Right, get started. I'll come around and help you if you need it.